Hello everybody and welcome to this new chapter of the 3D game programming video series for WebEngine 2.0. In the past video we start creating the different behaviors, the different code for the game, especially the asteroid field, the ship behavior, the ship management. And in this new video we will finish the code, and for now we will add the game logic, the collision detection. For example, if we click on the simulate button and we move the ship through an asteroid, we have to stop the game to kill the ship and restart the asteroid field and the game. Another thing we have to deal with is the background. If you can see the stars in the background, they are not following the camera, they are not in the background. So we have to adjust the follow behavior for this new scenario. So let's start with it. The background entity, which has the stars and the pretty cool planet. We will add this new follow behavior, but we will add new properties in the code. Here we have the Visual Studio solution with the project. So we want to make different the camera following behavior and the background following behavior, because in the background following behavior we don't want the background to rotate with the camera, and we don't want to make the following smooth. So let's make two different properties to change the behavior. The first of all will be smooth follow. And the second one will be rotating follow. Both of them has to be serializables, so we put the data member property. And in the update method, we will try to differentiate between the two different behaviors. So this code is for the smooth follow and rotating follow. So the first of all, we have to add the rotation update inside an if statement. And this is the smooth follow code, so we'll put inside this smooth follow if statement. So otherwise, this will be a direct follow, so we have just to, we can copy the code, but in this time the position and the rotation will just be directly the target position in this case, and the target rotation in this case too. And the rotation also inside the rotation follow statement. We compile, go back to the editor, reload the project, and we can see the background. The new properties, we don't want to follow the rotation and follow smoothly, but we do want the camera to do that. So we select the camera holder, follow behavior, and check these two new properties. I forgot to add the target entity, in this case the default camera 3D. So if we click on the simulate button, now we can see that the stars are in the background and they're not moving, and they are following the camera but not rotating along with it. So perfect. The next thing we have to do is just an enhancement of the spawning behavior of the asteroids. If you can see, the asteroids are showing just instantly. So we want to add like a fading effect, scaling effect, and we will call it spawn behavior, and we will add it to every asteroid. It's a really simple behavior. So let's go back to it. Add a new class in the project. And it's a behavior and serializable. So we make the data contract attribute. First of all, we have to add the transform property as a required component. Okay, we add the addEth method. So we will create a new method here, which is called spawn. In this method, we will store the current scale of the asteroid and then set it to 0. And in the update method, we will start scaling the asteroid until the final scale. So we have to store the end scale and just put a flag to tell the update method where have to change the scale. And set the scale to 0. Okay. So in the update method, if it's spawning, we have to update the scale. We will make a smooth scale. And we will make smooth just adding like a small step every frame. For this time, it can be just this value. It's just small steps, so it will be smooth. And set back the scale. And if the scale is bigger than the end scale, just for example the x value, we disable this is spawning flag, so everything will be like before. So we have a behavior here that update the scale, and to add it to the asteroid, we have to go to the asteroid manager in the method that we create the asteroid. Here, we will rename it to just asteroid here, and we will add this spawn behavior here. And when a new asteroid is showed, like here, we will call the spawn method. Like this. So we'll rebuild, go back to the editor, reload the project, and if we click here, we can see that the asteroids are like appearing like much more smoothly, much better. So they like they are like coming in our way. It's really much more beautiful. Next stop, creating the collisions. So we start adding a sphere collider 3D to the chip. Here. So for this game, a sphere collider is just accurate enough. We don't need a mesh collider. Next, we want in our game to separate two states. The first of all is when we are playing within the asteroid, but when we crash with an asteroid, the ship will explode and the game will be in a game over state. And then after maybe 3 seconds, the game will start again. So the next thing we have to do is just create that flag in the asteroid manager. maybe just is game over state or is game over. This code we replace here, and in this area we have to detect the collision with the ship and the asteroid. So first of all we have to iterate through the different asteroids, and for every asteroid we have to get its sphere collider and check if it's intersecting with the ship collider. So if the asteroid collider intersects with the ship collider bounding sphere, that means that we have to destroy the chip and set into the game over state. Well, this is a property, so we have to just pass the variable like this. So in this case, we will call a new game over method. The first of all we have to do here is just setting the game over flag. Then we have to set the game over time to start counting back, and then we have to tell the ship that it has to be destroyed. So let's go step by step. We will create the remaining time. And we will set the time to maybe 3. We can store like a constant here, but no, it's fine. Now in the game over area, we have to update the remaining game over time, just subtracting the game time total seconds. And when the remaining time is under 0, we have to reset the game to start at the beginning. So we will call a method called reset. So in this method, first of all, we have to hide all the asteroids, then call another reset method of the chip to place it into the 0 point and update its speed. So we set the is visible property to false. We disable the game over flag. And then we have to call a reset method of the chip. Getting the chip behavior, calling a new method called reset. We have to create a reset method and a game over method. So let's create them. In the game over method, we will make the ship invisible. So we will call the owner is visible to set to false. And to the reset method, we will set back to visible to true. Also in the reset method, we have to set the position back to 0. And the rotation also to 0. Update the current speed with the initial speed, as we did in the initialize method. And here in the game over, we have to set this current speed to 0. So, okay, I think it's nice for now. We create like a collision detection. We made the game over state. So when we collide with an asteroid, the game is in game over state for 3 seconds, then the game resets. So if we compile, go back to the editor. So if we simulate the game now, we can see that if we crash with an asteroid, after 3 seconds the game will be reset and the ship is destroyed. Crash. So now we have to add the visual effects. We have to add an explosion, we have to add sounds, and we have to add particles. But that's better for the next video. And I hope you enjoyed finishing the code, finishing the behaviors, and finishing our game logic. And stay tuned for new videos in the upcoming days. Thank you very much.